Hello, I'm Doug Collins. I'm an extension specialist and soil scientist with WSU. I'm at the Puyallup Research and Extension Center, and I'm going to share some research today about promoting cover crop success with compost and fertilizer. This research was conducted on farm at 4 Elements Farm in Puyallup, Washington. And one of the things that 4 Elements is concerned with is improving their soil quality. One of the comments I've heard from them is we can't even grow cover crops on our land. This is land that was in commercial squash and corn production for many, many years, and they run an organic farm, and so are interested in improved soil fertility and quality. Have attempted to use cover crops in that and found that even cover crops don't grow so well in parts of their farm. So we conducted a 2-year experiment at 4 Elements, and a couple of things that we took into our trial were, one, we used named cover crop varieties. This is important, I think, going forward in terms of using cover crops as a tool to improve soil fertility and soil quality. We make sure that way we have more of a chance of success from year to year or from seeing consistent results. We used with and without compost treatments, and then with and without organic fertilizer. And then we also targeted the planting rates on a seeds per square foot basis. We seeded in September, mid to late September, both 2018 and 2019. And for grains, we had targeted seeds per square foot of 42. And then, or this is more like live plants per square foot is what we're targeting. Vetches 7, Berseem clover 57, and Balansa clover 26. And you can see these are the plants that we used in the trial. So 3 vetches, 3 grains, and 2 clovers. And what that converted to in terms of pounds per acre, which many of us are more familiar with, was around 79 pounds per acre. And these are target live seeds of the Aristic rye, 94 of the Rinzabruzzi rye, 152 of oats, Purple Bounty, 18 pounds per acre, Common Vetch, 40 pounds per acre, and the Woolly Pod Vetch, 25 pounds per acre, and then the clovers at 12 and 3 pounds for the Berseem and Balansa clovers. This was a split plot design with 4 replications. So the main plots, or the largest plots, were where compost was applied. So that would be this brown area. And then the first split was variety. So you can see one subplot, in this case, frosty clover, the whole subplot's receiving that. And then half of each subplot, fertilizer was applied. And this just shows, again, the information about the target seeds per foot, what that meant in terms of target pounds per acre, and then our actual seeded pounds per acre in 2018 and 2019. So we did a decent job of trying to hit those targets. And we're fairly consistent from year to year. Some of the timeline for amendment for the field operations. Again, we soil sampled before application of compost, so early September. Compost was applied mid-September. In 2018, this was a rate of 2.6 dry tons per acre, and in 2019, 7.1 dry tons per acre. And then soil was tilled immediately after that. Fertilizer was made on the same day of planting, fertilizer application, so 30 pounds of nitrogen per acre with the feather meal 1100, and then cover crops were seeded. We did both years a post-application sampling in just one of the cover crops, one of the clovers actually, just to see how that fertilizer application and that compost application made weeks before affected the germinating and growing cover crop. You can see that in 2018, there was very low available nitrogen in these plots, so 3 parts per million nitrate, 2.1 parts per million ammonium, before application of the fertilizer and compost. What these data show is that in the fall following that compost and fertilizer application, there was more ammonium available with the compost and than without compost. So this is the ammonium. So compost had an increase on ammonium application. Oh, I'm sorry, this is with the fertilizer. So fertilizer increased the ammonium concentration in the soil following application, and then compost increased the soil nitrate following application. 4 weeks post-application. So we did see a bump in available nitrogen with both compost or fertilizer. With the compost, that came more as a nitrate bump, whereas with that chicken meal fertilizer, it came more as an ammonium bump. And so this shows a plot of oats taken a few weeks after seeding in the fall winter of the first year of the trial. And so this is a plot that received compost, and here you can see the fertilizer effect with fertilizer in the top picture and without fertilizer in the bottom picture. And these are some of the other characters in the trial. In the middle, as you'll see later, Lana woolly pod vetch was probably the winner among the vetches, and we'll have lots of data to show that. You can see the common vetch that we use, Languedoc, which has a great name but did not fare as well in this trial. And then the purple bounty vetch did a little bit better than this picture would suggest. So these are taken sort of midwinter in the first year of the trial. And then the two clovers, as we'll see, neither did very well in either year of the trial. So we were very careful to try to do operations, especially around incorporation, in line with the phenological stage of the cover crop. So these data show the phenological stages for the grass cover crops in 2019 and 2020. So in the spring of 2019, following the fall 2018 seeding, and 2020, same thing with the fall 2019 seeding. And we use the Zadok scale here. So what is kind of important here is around that 40 on the Zadok scale. That's when we reach boot stage. And then following boot, we get head emergence and then anthesis at the 60. So general rules here, if you are going to incorporate a grass species, it's good to do that incorporation at around boot stage. Don't want to wait too much, actually, yeah, around elongation. So early, around the 40s, maybe late 30s, is a good time to incorporate to avoid nitrogen immobilization. So we were a bit later than that in 2019 and a little closer to that target for the rise in 2020. And oats, same thing. The other thing to notice is the big difference here between the rate of phenological progression between the rye and the oats. So the rye are ready to be incorporated much sooner than the oats would be, or you have more time potentially with the oats. And this kind of shows that point here. So the picture on the left shows oats and rye, April 25th, 2019. So this was about the date that the rye was terminated for our study. And you can see the oats are still, you know, in that early elongation stage, or not there yet even. And then this is what the oats look like on the termination date. So starting to get some heading oats when we did terminate them. These data show the, bar is in my way. These data show the above ground biomass for the grasses with compost, without compost, and with fertilizer and without fertilizer. And there was a very strong fertilizer effect and a strong variety effect. So you can see, you know, oats outperforming the rye, especially with compost in 2019. But overall, pretty much better than rye in terms of overall above ground biomass. And then the fertilizer effect is very strong across the grasses. So we had a highly significant fertilizer effect. And we saw an average 46% yield increase with fertilizer with the grasses. Compost effect was 0.26 p-value in 2019 and 0.13 in 2020, so not a very strong compost effect. This is, again, looking at phenological progression. This is vetch this time, and the scale is different. This is a Mishler scale that we use, and it is 1 means 100% vegetative, and then 2, 3, 4, 5, 6 are sort of a progression in terms of how much of the plant or field is flowering. So a 2 is a 20% flowering on up to a 6, which would be 100% flowering. And so our target for termination would be during the flowering stage, maybe late flowering. We certainly want to terminate before we get any pod development. And again, here you can see the difference in species and their termination. So the common vetch, or the Languedoc is the one we used, reaching flowering, late flowering, pod development, mid-April in 2019, whereas the Lana vetch was more like early May, and Purple Bounty was still had a ways to go. So Purple Bounty is a hairy vetch, still had a much later development than the Lana, or especially the Languedoc. And I think I saw these pictures already, so you can see the Lana doing well. Languedoc looked pretty good in 2019. And then this just shows the timing of flowering and also the types of flowering. So early flowering in the Languedoc, sort of, you can see some flowering in the Purple Bounty, but it was much lower. You could see when we look at all the data. And then on May 15th, and then May 15th with the Lana vetch, full flower, starting to go towards pod development. So this is the above ground biomass with the vetches, and they were harvested on the different dates due to the phenology. And there was no strong compost or fertilizer effect. A slight increase in compost yield with compost, slight increase in vetch yield with compost, but not significant. The clovers, I'm not showing a lot of data on. I'll show one sort of overall biomass graph here in a second, but they just didn't perform very well in terms of biomass production. We did have a couple of plots, and I think this is one of my take-home messages, that the legumes, there would be like the occasional plot that did really well. So grasses, on the other hand, would be very consistent from plot to plot across the field. Legumes, I'd say especially the clovers, were more inconsistent across the field. So that might have to do with weed pressure, which can vary considerably. But interestingly, those grasses would be consistent across the plots in the trial, even with that varying weed pressure. So this shows the overall above ground biomass with all of the species trialed. And so you can see the oats doing really well, rye next, and then Lana vetch kind of up there almost with the rye in terms of above ground biomass production, and the clovers not really producing much biomass at all by the time termination happened. So here, this is asking the question, did compost and fertilizer affect the concentration of nitrogen in the grasses? And the answer was no. So even with, we see a big biomass effect, but not seeing a difference really in the concentration of nitrogen in the grasses. Same question with the vetches. Did the concentration of nitrogen, was that affected by compost or fertilizer? Again, here the answer was no in terms of concentration. But what about the content? So here we would take the concentration times the biomass, and was there effect from compost or fertilizer on the content of nitrogen? So if you look at that whole cover crop, there's a bunch of nitrogen in there. How much is in there? That's what we're asking with this, with these data here. And so of course there was a huge increase in the biomass with grasses with fertilizer. So we see a corresponding increase in the nitrogen content with fertilizer. So same concentration, but more of the nitrogen. I'm sorry, more biomass. And with vetches, Not a strong relationship. It wasn't significant fertilizer or compost on the content, but there was a compost by variety effect in 2020. So you can see, for example, with Lana Vetch, looking like more biomass with just that variety with the compost. So we see this interaction. Overall, a 32% increase in the nitrogen content with compost among vetches, but not a significant effect. And then this shows the nitrogen content across all the species tested. And this is, this shows us quite a bit, obviously. So vetches are really going to be valuable in terms of adding that nitrogen content to the cropping system, something we can count on to utilize for the following crop. It is also, there's quite a big difference in the species. So Lana Vetch doing much better than Purple Bounty Vetch or the Languedoc Vetch. And then this is asking the question of, okay, after we incorporated the cover crop, what is the nitrogen availability a few weeks after incorporation? And was there an effect with fertilizer or compost on that? The answer was no, there was not. The fertilizer, this is only 1 year, so this is just 2019, following incorporation in 2019. And no compost or fertilizer effect with the grasses on that nitrogen availability. And with vetch, there was surprisingly almost a fertilizer effect, so 0.08 p-value for vetch availability following fertilizer, which is very interesting because we didn't see a big effect on biomass or nitrogen content with fertilizer. And then this is showing all the cover crop species and the nitrogen availability. So here we see the potential to immobilize nitrogen with grasses despite fertilizer or cover crop effect. These are all these are with the all these plots where it had compost and fertilizer, and you can see that nitrogen availability after incorporation of the cover crop is really most affected or most increased by vetch, especially Lana Vetch, which performed well both years. So in conclusion, we saw strong nitrogen fertilizer effect on all grass species, biomass and nitrogen contribution, but no fertilizer effect on legume biomass, but a variety by fertilizer interaction on legume nitrogen content. Soil had lower nitrogen content than vetches following incorporation. Biomass was larger with compost in grasses and legumes, but not significantly. There was greater variability across plots with legumes, perhaps because of lower competitiveness against weeds. And I would also emphasize that variety was critical to success, especially with vetch. Thank you very much.